Hello everyone! In previous lessons, we have learned about the high strength and toughness of steel. It is like an almighty superhero in the construction industry. However, steel also has fatal weaknesses. It fears corrosion and fire. Please look at these two pictures. The first shows exposed steel bars at a port, covered with heavy rust that even cracks the surrounding concrete. The second displays severely rusted bolts at connection joints. These shocking scenes remind us, without proper protection, even the best steel may lead to serious disasters. Today, we will face these weaknesses directly and find effective solutions. First, why do steel bars rust? Is it simply a chemical reaction between iron and oxygen? It is more complicated than that. Think about a steel bar inserted in water. Which part rusts first? The boundary between water and air. Essentially, rusting is an electrochemical process. In this microgalvanic cell, for anode, iron loses electrons and turns into ferrous ions. This is the source of rusting. For cathode, oxygen and water gain electrons and form hydroxide ions. When these two combine, loose rust is produced continuously. As long as iron, water, and oxygen exist together, the corrosion reaction will keep going. Therefore, the core principle of anti-corrosion protection is to cut off this electrochemical circuit. Let's look at three main methods. 1. Modification. Give steel natural immunity. The most direct way is to use corrosion-resistant steel. By adding specific alloy elements, we produce stainless steel or weathering steel. This is like vaccinating the steel itself to strengthen its resistance. 2. Isolation. Apply protective coatings. The second method is to separate steel from water and oxygen. For example, by applying a layer of metal to the steel surface. Common metal plating includes tin plating, like tinned iron sheet, and zinc plating, galvanized iron sheet. But are these two coatings the same? This relates to the metal activity series: potassium, calcium, sodium, magnesium, aluminum, zinc, iron, tin. For zinc plating, that is, galvanized iron sheet, zinc is more active than iron. If the coating is scratched, zinc will corrode first to protect the iron underneath. For tin plating, that is, tinned iron sheet, tin is less active than iron. If the coating is damaged, iron corrodes faster than tin, accelerating rusting. Therefore, although both are protective coatings, the galvanized layer is clearly more sacrificial in its protective effect. 3. Electrochemical protection. Use a sacrificial metal. Since corrosion happens when iron loses electrons, can we let another metal lose electrons instead? Sure we can. Sacrificial anode cathodic protection. Attach a more active metal such as zinc or magnesium beside steel. During corrosion, zinc or magnesium acts as the anode and corrodes first, protecting the steel. In pressed current cathodic protection, an external electric current is applied to continuously supply electrons to the steel, forcing it to remain in an electron-rich state and thereby preventing corrosion. Besides rust, steel fears fire. When the temperature exceeds 600 degrees Celsius, the strength of steel almost drops to zero. To prevent this, fireproof coatings are applied in two main types. 1. Thin type fireproof coating, that is, active intumescent type. This kind of coating remains thin under normal conditions. Once exposed to fire, it will expand and form foam. The principle is that the formed foam layer features a loose and porous structure, which can isolate oxygen and insulate heat just like a cotton quilt. In addition, the foaming process absorbs heat, which can effectively reduce the overall temperature and prevent the spread of fire. 2. Thick type fireproof coating, that is, passive heat insulation type. This coating is thick in its original state. It will not foam or change in volume when exposed to fire. Principle: it relies on its own extremely low thermal conductivity to slow down the heat conduction to the interior of the steel material like a thick wall. At the same time, the components in the coating will decompose to release non-combustible gases such as carbon dioxide and absorb heat when encountering fire, further achieving the effects of flame retardancy and temperature reduction. Note that the construction thickness of thick-type coatings must be strictly controlled. If the thickness is insufficient, the fireproof effect will be greatly reduced. Everyone, up to this point, we have finished all the content about steel materials. We have covered everything from smelting classification to mechanical properties, and from microscopic chemical compositions to macroscopic protection measures. We should not only know how to utilize the strength of steel, but also learn to make up for its weaknesses through technical means. It is hoped that you can apply this knowledge to future engineering practice, so that our buildings can possess both steel-like firm frameworks and protective armor to resist the erosion of time.